Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving largest divisible subset. So the problem states that we are given a set of distinct positive integer nums, and we want to return the largest subset answer such that for every pair, one or the other of the numbers can divide to the other number and have a remainder of 0. And if there are multiple solutions, we can return any of them. So if we look at this example, for here the output is 1 and 2 because 2 can divide by 1, but we can also return 1 and 3 because 3 can divide by 1. So the longest subset that we have is a length of 2. And for this example, we can just return the whole array because for each of these pair, one of the numbers can always divide into the other number. All numbers could divide by 1, 2 can divide by 1, and 4 and 8 can divide by 2. 4 can divide by 2 and 1, and 8 can divide by 4, and 8 can divide by all three of these, so that is why we can return the whole array. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve the problem is with dynamic programming, and what we would do is we will first sort the array because a smaller number can never divide by a larger number with a remainder of 0, but a larger number can sometimes divide by a smaller number with a remainder of 0. So for example, 2 divided by 4, the remainder would not equal to 0, but if you do 4 divided by 2, the remainder would be 0. So we will initialize this DP array with each index initially only containing the element at that index. And what we will do is we will start iterating backwards. And at each iteration, we will check every previous number if it can divide by the current element. And if it can, then we will add all the elements in the previous DP to the current element. And if it happens to have a larger length, then we will update that DP. So for example, if A can divide by 4, then we will add 4 and 8 into one array. And since it is larger, meaning it has a length of 2, we will update the DP. And at each iteration, we will also update the result with the array with the largest length. So let's go over this example real quick. So first we are at the end of the input array. We see that A can divide by itself. So we keep the DP as 8 and the result currently, this is the largest. Now we move on to 4. We see that A can divide by 4. So we update the DP with 4 combined with the DP here. And we will update the result because this is the largest array we have right now. And now we come to index 2. We see that 4 can divide by 2, so we'll combine 2 with the array over here. And we see that 8 can also divide by 2, but this is still larger, so we keep this one. And then we will update the result to this array. And finally, we come to index 1. 2 can divide by 1, so we combine 1 with this array. 4 can divide by 1, but this array is still larger. 8 can also divide by 1, but this array is still larger, so we keep the DP as this. And then we update the result with the largest length, which is this one. And then we can return this as our result. So the time complexity would be O of n squared because we will have to iterate through all the elements, and at each element we will have to check that element with all the previous elements in the array, so it can take up to n squared time, where n is the number of elements in the array. And the space complexity would be O of n because the length of the DP depends on the number of elements in the input array. So now let's get to the coding part. So first we will sort nums, which is the input array. And then we will set DP to the array of the number at the element, so num for num in nums. And then we will initialize the resulting array to an empty array. And now we will loop backwards. So for I in range, length of nums -1, -1, -1. So -1, comma, -1. And -1 again. And now we will look from j to range I plus 1 to the length of nums. So basically for each element, we will look at every element to the right of it. That's why it's n squared. So if nums of j could divide by nums of I, so if it has a remainder of 0, then we will set a temporary array to the nums of I plus dp of j. And if this temporary array happens to have a larger length than dp of I, then we would update dp of I to that. Otherwise, we would just not keep it, so it will say else dp of I. Else dp of I. Yeah. And then afterwards, we can update the result to dp of I if the length of dp of I happens to become larger than the current result. If not, then we just keep the result. So else result. And then finally, we can return result. Let's see if it works. Okay, perfect. Thank you all for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.